Hey everyone, continuing from the previous video, we'll be looking at the power rule again, but now we'll be looking at fx to the power of n such that fx is actually an algebraic expression. So we're not looking at the trigonometries yet, we're not looking at the logarithms yet, but just looking at the algebraic functions so far. Alright, so let's start off with a simpler example. Let's say I want to integrate 2x plus 1 to the power of 3. One way to do it is to expand everything and then integrate it term by term. But the quicker way is actually, well, using this idea of the differentiation power rule. So in differentiation power rule, we had this, right? Y equals to fx power n dy dx is simply bring down the power to the front, reduce the power by 1, and then you differentiate inside. Let's take a look at whether we can apply this formula here to this. So integration is the reverse, right? So first, same thing as the previous video, increase the power by 1. Okay, so far so good. Divide by the new power. Alright, fantastic. But you notice that inside the bracket, there's a derivative of 2, right? And going by this form, we have to also differentiate. We have to also divide by the derivative, which is 2. So I divide by another 2, and then plus a c. Therefore, my answer becomes 2x plus 1 whole thing power 4 over 8 plus c. We can check our answer, actually. So if you want to check our answer, so differentiate 2x plus 1 to the power of 4 over 8 plus c. So firstly, differentiating a constant is 0, so I can ignore the second term. For the first term though, well, bring down the power to the front, reduce the power by 1, and then you differentiate inside. And you notice, I get back 4 times 2 is basically 8, and I get back 2x plus 1 power 3 is the same answer as my integral, my function in the integral. So that is the correct answer. But does it hold true for all examples? Answer is no, because just one change and it's actually impossible already. So let's say I now have 2x squared plus 1 whole thing cube. Let's try to use the same step, alright? So okay, I increase the power by 1, we divide by the power, and now I divide by the derivative inside, because I have to divide by the derivative. So the derivative inside is 4x. So okay, divide by 4x. However, this is actually wrong, because what you have done is that you have introduced a new term, new algebraic term, and you're not allowed to do that. You're not allowed to introduce a new variable, whether is it the same variable or another different type of variable. You cannot introduce a new variable term. So this is a illegal method, and this actually will result in the wrong answer. Instead, for this question, you have to expand and then you differentiate. Then you integrate. So what I mean is this: so expand, right? So 8x power 6. So integrating 8x power 6 plus 6x to the power of 4 plus, sorry, it's not 6x to the power of 4, it's 12x power 4 plus 6x to the power of 6x squared, and then plus 1 dx. Hope I got that correctly. Seems like I did. Okay, now I perform the integration on each term. So I'll just keep it quick. So this would be my final answer. Okay. So in short, if fx is a linear algebraic expression, then fx is the form kx plus h, so basically x power of 1. Then if we want to integrate fx to the power of n dx, the answer is simply, well, increase the power by 1, very similar to x to the power of n, divide by the power, and then now don't forget to also divide by the derivative inside. And because the derivative is a constant, since, well, it'll be in this case, it'll be k, so you won't run the risk of introducing new terms. So, like I repeat again, you cannot introduce new terms, and therefore this is only valid for fx that is a linear algebraic expression. Of course, there will be a more general form, but we will leave that to the future videos after we cover all possible types of integration techniques.